Dear students, the next topic which we are going to discuss is design procedure of clock sequential circuit. So this is one of the important topics of our third unit. So let us discuss how exactly we'll have to design the clock sequential circuit. Okay. So this the design of clock sequential circuit consists of 9 steps. So step number 1 is we'll have to draw the state diagram. So this state diagram will be given in the question, and we know that the state diagram signifies the behavior of the circuit, okay. The step two is we'll have to obtain the state table, okay. So we already discussed that what is a state table, what is state, right? What is the present state and next state, everything we have discussed. So based on that, we'll have to draw the state table, okay. So let me write the topic. So it's a design procedure of clocked sequential circuit, okay. So the step 3 is state reduction, okay. So this state reduction is done if it is only required, and this state is nothing but if any state gets repeated, we'll have to reduce that. That is what is called as state reduction. And step 4 is state assignment, okay. It is state assignment, okay. This again, if the state has not been assigned, we'll have to assign. So if required, this step is carried out. Step 5 is you will have to determine the number of flip-flops used. Determine the number of flip-flop used. And step 6 is we'll have to decide the type of the flip-flop, okay. So this sometimes will be given in the problem itself. Otherwise we can use whatever flip-flop we are interested to use, okay. So the step 7 is we'll have to derive a very crucial or important step is to derive the circuit excitation table. This is very, very important. This excitation table is again got from the state table, okay. And next we'll have to the step 8 is we'll have to obtain the expression for the flip-flop input as well as the circuit output. And the last step is we'll have to implement the circuit, okay. Implementation or implement of the circuit, which is called as the logic diagram. So these are all the 9 steps which is being used to design the clocked sequential circuit, which is very, very important, okay. So in the sequential circuit which is given to us is, okay, the problem which gives the state diagram is something like this. This is what is the state diagram. So there are 4 states which has been mentioned, okay. So let me draw the diagram for you all first. So the state is 0, 0 is one state, 0, 1 is the second stage, third stage is 1, 0, and the fourth stage is 1, 1, okay. And let me complete the diagram for you all so that problem analyzation will be easier, okay. So you have 0 by 0, and here you have 1 by 1, here you have 0 by 0, you have 0 by 1, 1 by 0, here 1 by 0, and here it is 0 by 0. So dear students, when we discussed the types of sequential circuits, when we spoke about the Moore and the Millet circuit, so the representation we have already discussed, and here it is the Millet type of circuit where you can see the input being represented on the numerator and output being represented in the denominator, right? So here using this, so first step is over, which we have the state diagram which is given, and they're asking us to design the sequential circuit using T flip-flop, okay. This is the circuit which is given and they're asking us to design it using the T flip-flop. And kindly note that any synchronous circuit asked should be designed in the same methodology or the same steps should be carried for any circuit given. Clear? The next thing, or the next important thing, is to derive the state table. Okay, to derive the state table we need present state. Okay, we need the present state. Okay, and we have already discussed what is this present state. Okay, and next state, and you will require the output. Okay, so in the present state you have, say, the variable AB. So in the next state you will have to check the condition of the variable AB using the input. I'll draw the state table in the next page, okay, so that you can see it clearly. So based on the diagram, let me draw the diagram quickly for you all. So here it is, 0 1. So this is 1 by 0, which represents the input and output, 0 by 0. And here it is 0 by 1. Here it is 1 by 0. Here it is 1 by 0. And here it is 0 by 1, which indicates your input and output. From here it is 1 by 1. Now consider this, okay. Now this is what is your sequential circuit which is given. So it is, as I told you, it's represented in the Mealy form where your numerator represents the input. So let me write this as input for you all, and this is your output. Okay, now let us draw the state table. As I told you, in the state table you have a present state, I'll write it as PS, and you have the next state, okay, NS, and you have the output. Okay, so the states here is, you can see that there are 4 states, 0 0, 0 1, 1 0 and 1 1. Okay, so these are the 4 states. Now so we'll have to discuss what are the condition of this particular state when the input is equal to 0 and when the input is equal to 1. Okay, and similarly, what is the output Y when the input is 0 and when the input is 1. Okay, now just listen here carefully. Now you have the states 0 0, 0 1, 1 0, 1 1, right? And I told you that here when you consider the state 0 0, okay, now you can see that when the input X is equal to 0, that means you have the numerator as 0. That means, or that signifies, your input is 0. When the input is 0, what state or what is the condition of this particular state? 0 0, correct? Now when 0 0 has the input 0, it is coming to the same state itself, correct? So I'll represent this as, when the input or when the state 0 0 is in the input 0, it is coming to the state 0 0 itself. Let me name this as AB and let me name this as AB. Okay, now similarly, when the state 0 0, when its input is X, when the input X is equal to 1, that means the state 0 0 when its input is 1. See, when the input is 1 means the arrow should protend, or the arrow should move from the state 0 0. Okay, so the state 0 0, when the input is 1, it is going to the state 1 0. So my answer here, it is 1 0. So at this condition, when the state 0 0, when the input is 0, what is its corresponding output at that time? It is 0. So this I'll have to fill in this output column. Similarly, state 0 0, when the input is 1. Where is the input? 1. Input is 1. At that time, what is its corresponding output? It's 1. So that I'll have to fill here. I guess you have understood. Now let us see the next state, 0 1. Okay, the next state 0 1. So 0 1, when the input is 0. So input is 0 in the sense you have to check for the numerator, which is 0. So when it is 0, it is going to the next state 1 1, correct? So at that time, so let me fill this. It is going to the state 1 1. At its corresponding time, what is its output? It is 0. So this I'll have to fill it over here, correct? So 0 1, state 0 1, come back to 0 1. 0 1, when the input is 1. Where is the input? 1? Here is the input 1. So 0 1, when the input is 1, it is going to the state 0 0. right? I'll have to fill this 0 0. At its corresponding time, what is its output? Sorry, what is its output at this corresponding time? It is 0. So this I'll have to fill up here. Okay. So similarly, let us fill this. So 1 0, the state 1 0, when the input is 0, input is over here. So when it is 0, it is coming back to the same state. So fill this as 1 0. At that state, what is its output? It is 1. So let us fill this 1. So 1 0, 1 0, when the input is 1, when the input is 1, so over here, so it is going to the next state 0 1. At that time, what is its output? It is 0. Okay. Then the stage 1 1. So the 1 1 is here. So 1 1, when the input is 0, it is going to the state 0 0. At that stage, its corresponding output is 1. And 1 1, when the input is 1, it is going to 1 0. Its corresponding stage is 0 over there. Okay. So this is what is our state table. So our second step is over. We have completed our state table. Okay. Now after the state table, we'll have to check if there is any stage or any state that is repeating, and we can see that there is no state that is repeating. So the reduction of state table is not required over here, and also the state assignment, because it's already been assigned here. In certain problems, instead of 0 0, they would have given us as A, B, C and D. In that case, we'll have to specify A as 0 0, B as 0 1, C as 1 0 and D as 1 1. It is not required over here because already the state is been assigned with values as 0 0, 0 1, 1 0, 1 1. So we skip the state assignment over here, and next we go to the number of flip-flops to be used. Okay. So how do you determine the types of flip-flops to be used or the number of flip-flops to be used? Since it is a sequential circuit, we know that flip-flops plays a very important role, right? So the flip-flops to be used is, there is a formula or there is an expression. So number of states is equal to 2 raised to the power of m, where m signifies your number of flip-flops to be used. Okay. So what is the number of states over here? We have 1, 2, 3 and 4, right? So the number of states used is 4 is equal to 2 raised to the power of m. So what will be the value of m to make the states equal to 4? So obviously it is 2, right? So 2 is the number of flip-flops that I have to use. Okay. And deciding the types of flip-flop to be used, if given in the problem specifically, okay, you'll have to use the flip-flop mentioned. Like in this problem, they've asked us to use T flip-flop, right? So I will have to use T flip-flop, and that T flip-flop I can name it as, say, TA and TB. Okay. If not specified, you can use any flip-flop. It can be JK, it can be D, it can be SR. Okay. So here I am being asked to use TA and TB because it is T flip-flop over here. Okay. So the next important step or the next crucial step which I'll have to derive is, let me turn the page for you all. So the next crucial step is the excitation table, which is very important. This excitation table is obtained from the state table. Okay. So how do I fill this excitation table is, you will have to have present state, okay, and then you have to have the input, then you will have to have the next state, and then the major flip-flop inputs, and then your output. Okay. Now the present state, we know that you have AB and your input is X, and the next state again AB. In certain problems, you can see that the next state would have been given as A plus and B plus. That again indicates it is the next state. Okay. So flip-flop inputs, let me take it as TA and TB as discussed, and output as Y. Okay. So this gives the outline of our excitation table. And see here, if you would have noted, in case of the state diagram or state table, we had 4 states, right? and the 4 states was derived using the 2 inputs for the condition when x is equal to 0 and for the condition x is equal to 1, correct? So here if you analyze in that way, you have 8 combinations, right? 4 for input x is equal to 0 and 4 for input x is equal to 1, correct? So those 8 combinations I am going to list like this: 0 0 0 0. I am repeating for 2 times: 0 1 0 1, 1 0 1 0, 1 1 and 1 1, correct? Now the input this is going to be splitted for 0 1 0 1 0 1 0 1. Hope you guys have understood this. So let me bifurcate the inputs because everything is zeros and 1 and there are possible cases for us to get confused, correct? Now the next state, how do you determine the next state is, the next state has to be determined by the state table, okay, which we have already derived, okay. So let me show you all the state table which we derived. Now see here, this is the state table which we have derived, right? Now for 0 0 condition, when x is equal to 0, what is the state? It is 0 0, correct? So I am going to fill this, it is 0 0, okay. At the same time, when it is 0, what was the output? It was 0. So you have to check your state table and fill up this column, okay. So checking the state table, let me fill up this. For 0 0, when the input was 1, from the state table we have it as 1 0, okay, and the corresponding output at that time is 1. For 0 1, when the input is 0, it was 1 1 and the corresponding output is 0. For 0 1, when it is input is 1, we have 0 0 and the output being 0, okay. For 1 0 0, you have it as 1 0 is the input and the corresponding output is 1. For 1 0 1, it is 0 1 and it is 0 over here. For 1 1, it is 0 0 and the output is 1 over here. For 1 1 and 1, it is 1 0 and the output is 0. So these are the columns that can be filled with the help of the state table. Now how do I fill the inputs for the flip-flop TA and TB, okay? Now this is very important. Students, note this. The flip-flop inputs TA and TB can be obtained from the excitation table of T flip-flop. Excitation table of T flip-flop, which we are already aware of, okay. So let me write that again for you all. So Qn is the present state, Qn plus 1 the next state, and T flip-flop inputs, okay. So 0 0 0 1 1 0 and 1 1. So for 0 0 you have it as 0, for 0 1 we have it as 1, for 1 0 it is 1 and 1 1 it is 0, okay. So this is what is our excitation table of T flip-flop. Now using this excitation table, now listen carefully, how do I fill this TA? Now TA can be filled by using, okay, the excitation table, okay. It is consider the inputs, okay, 0 and 0, that is you have to consider the present state A and the next state A, okay. So the present state A and the next state A is the inputs for your TA, that is you can have your fingers, okay, towards these two columns. So 0 0 as per the excitation table of T flip-flop is 0. So I have to fill it here as 0. The next condition 0 1, 0 1 it is 1. For 0 1, for 0 0 it is 0. Again for 0 it is, sorry, let me check it once again. 0 1 it is 1 here. For 0 0 it is 0. For 1 1 it is 0. For 1 0 it is 1. For 1 0 it is 1 and for 1 1 it is 0, okay. So using the inputs of present and the next state, I am filling up the TA inputs of flip-flop inputs using the excitation table. Now next, how do I fill up TB? By using the B input of present date and B input of the next state. These two gives me my TB, correct? Now you can have the fingers on the column so that you don't get confused. So 0, 0 gives me a 0, 0, 0 gives me a 0, 1, 1 gives me a 0, 1, 0 gives me a 1, 0, 0 gives me a 0, 0, 1 gives me a 1, 1, 0 gives me a 1 if I'm not wrong, and 1, 0 gives me a 1. Okay, so this is what is my TB inputs. So 0, 1, 1, 0, 0, 1, 1, 0 and 0, 0, 0, 1, 0, 1, 1, 1 are my inputs. So these TA and TB is nothing but my flip-flop inputs, and this is my outputs. Okay. My next step is, now we have completed the excitation table. My next step is KMap implementation. Okay, the KMap flip-flop implementation. Now, how do I do the KMap implementation? Okay, now I'll have to derive the KMap expression for flip-flop inputs, okay, and output of the circuit. Now for the input, for TA, so what will be my inputs? It is A and it is A, B and X are the inputs of my K flip-flop, right? So let me draw the cell of the K map. So it is like this. So here you have A, B and X. Okay. So for TA my inputs is A, B and X. So A, B and X, you know, you have 0 to 1, 1 combination. So I'll have to use 3 variable KMap cell. Okay. Because we are already done many problems in KMap. So you guys will be aware of it already. So let me write the variables 0, 0, 0, 1, 1, 1, 1, 0. Here it is 0 and 1. Okay. Now I am supposed to fill this inputs, right? For 0, 0, 0 it is 0. For 0, 0, 1 it is 1. For 0, 1, 0 it is 1, right? So let me fill that using or seeing your excitation table. Now let us group this. So this will be my first group and this is my second group, right? So what will be the expression of my TA? So here B is common. So B is common over here. Its corresponding column is X bar plus here if I take B bar is common and its corresponding column is X. Okay. So this is my expression for TA. Correct? Yes. Now let me take a fresh page for you all to show you all the expression for or the KMap simplification for the TB. Okay. Now considering the expression for TB, it is something like this. Let me draw the cell for you all. So it is ABX 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. Okay. So this again you will have to see the ABX inputs. So let me see the excitation table and fill this column up. Okay. Now how do I group this? So here I get a first group. Here I get my second group. And here I get my third group. Okay. So how do I write the expression? AB for one group plus BX for the second group and AX. Okay. So now we have got the expression for the inputs of flip-flops. Now let us get the expression for the output. Okay. So here you have the output. For the output we have AB and X. Okay. 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. So let me quickly fill up this column for you all. So 1, 1, 0, 0. So we have one group over here and the next group over here. So what will be the expression for the output? AX bar plus, since it's a single term, you have its corresponding row having A bar, B bar, the corresponding column having X, right? Okay, so this is my output expression. The last step is, now we have got the expression, the last step is the circuit implementation. Okay, now using this output expression and the input expression, let me draw the expression for TA. Okay, so using this two expression and my output expression, my final logic diagram will be something like this. Okay, so I have TA flip-flop. Okay, let me draw the TA flip-flop. A bar. Okay, and I have TB with QB and QB bar. Okay, so say this is my B flip-flop, this is my A flip-flop, and what do my TA says? B X bar using one AND gate and B bar X. Okay, another AND gate. So both of this is being ORed by the XOR. Okay, so this is my TA. Okay, I forgot to give the clock pulse, a common clock pulse. Okay, and I have for TB I have AB, BX and AX. Okay, there is 3 AND gates because of place problem. I'll just write over here. So this is my TB and this TB I'll have to get it back here. Okay, this is my TB. Okay, so this is my AB, this is BX and this is AX. As students, we have discussed lot of problems on how to draw the logic diagrams. I think you will not have any problems or issues in this. For output circuit, that's very simple. You have AX bar, okay, and you have A bar, B bar and X, a 3 input AND gate, A bar, B bar and X. So this is connected with an OR. Okay, this is your output Y. Okay, so this completes your entire design of synchronous sequential circuit. So you will have to follow the 9 step irrespective of any problem that is given. Hopefully you have understood this problem. For any doubts or clarifications, you can revert back to me. Thank you.